Okay, so now we are going to talk about inverse functions. And inverse functions is definitely something that we've spent a lot of time about in grade 12, pre-calc 12. So let's go over that a little bit to start with. So if we have, for example, f of x equals x to the 3, just a normal function, we could write out just a quick table of values. When x is equal to 1, y is also 1, of course, because 1 cubed is 1. And when x is equal to 2, it's 8, 3, 27, 4, 64, and so on. But then, say if the inverse of this would be 1 over x cubed, which if we write that out would be the inverse of x is equal to 1 over x cubed. Or another way to write it is just x to the 1 over 3. So if we were to do a quick table of values for this, what we'd end up with is x, y is same at the start 1, 1, but instead we'll have x value of 8. When x is 8, we'll have 2, and when x is 27, we'll have 3. When x is 64, we will have 4. As you can tell, it's almost the x and y values have flipped, if you want to call it that. So essentially, you could say in a normal function, x is your domain and your y is your range. But almost just to put it in almost a weird way, you could almost say that your x here is now the same values of what your y used to be in this case. So you can almost say it's your range, and your y would be like your domain. So the values for each, they completely flip. So exactly what your y value is now your x. So we move on to something that's more of geared towards calculus now. So the major key of it was Theorem 2 in the textbook, which stated that g prime of x equal to 1 over f of g of x. And essentially what this is finding the derivative of an inverse function. It's really, and the way we do that is through this formula here. So I'll explain a little bit of essentially what is happening. So in this case, we can let f be a function. This theorem really works. So if we let f be a function that is differentiable on an interval, and if f has an inverse function, which we will say is g, and then g is differentiable at any x for which f prime of g of x, write that, f prime of g of x, so essentially one of the composite functions, is not equal to 0, because of course we cannot have a 0 on the bottom of this inverse, and then this will give us our derivative of the inverse function. Okay, so let's do a quick example now. So if we have the function of f of x equals 3x minus 2, and if we quickly just graph this guy, just roughly, it'll be something like this, if not close. If I could do a straight line, but if we were to take the inverse of that, we'd get 5x is equal to 1 over 3x minus 2. If we wanted to get a general idea of what this is, we could think of it as, so our x value is now our y value. So this 0 and 2 is now going to be 2 and 0. So like this. Oh, come on. and then our whichever point this is here, that is now going to move. So yeah, well, no, let's just go to 1 and up here. So let's say this will now be down on the bottom. So now we're going to have a point over here. So then our new graph is going to be protruding. I want to say like that. So this would be our original f of x. This will be our f prime of x. So as you can see, pretty much all our values of x and y have flipped. So essentially, the angle is moved from essentially here is now here. And then that's exactly how the inverse is done.